design procedure, for actually loaded isolated square footing. Okay, the first thing, there are design steps for carrying out the design of footing. In that, first is size of footing. Okay, there are mainly two types. First, you can take square footing or rectangular footing. Now, in this first one, in the given data, the working load means P is given. The next one, assume weight of footing. Okay, usually it is from range of the 5% to 10% of P. And what is the P? The working load. Means you have to just add the 5 to 10% of the working load. Okay, then the ultimate bearing capacity of soil. Okay, means our foundation is going to transmit the load over the soil. So the value of soil bearing capacity, ultimate bearing capacity of soil, is also important. So it is nothing but the Pu is equal to 2 times of soil bearing capacity, short form SBC. Now the next one, factored load. Factored load is 1.5 times of P. P means working load and plus weight of footing. Okay, here you will get the factored load, means that is Pu. Okay, the next one, area of footing. The area of footing can be calculated by the factored load divided by Pu. Okay, this Pu is nothing but the SBC. Okay, don't get confused about what is Pu and what is P. That is SBC, means that the factored load, the area of footing, is equal to C factored load divided by, it is nothing but the, for A is equal to F by force by area. This is not A, this is sigma, means stress. Now the next one, if from that you get an area of footing, and after that there are two options, and that is square footing and rectangular footing. For the square footing, it is very much easy. Square footing is equal to, here in condition L is equals to B, right? So it is equal to in root area of footing. Okay, then you will get the size of the footing. Now rectangular footing, in rectangular footing there will be assume L is equal, assume L, and then B is equal to area of footing divided by L. Okay, it might be from the ratio of the column. Okay, it will more be easier. Now secondly you have to find upward soil pressure. Okay, now upward soil pressure, while estimating the upward soil pressure, you have to neglect the self weight of which, of footing. Okay, then upward soil pressure, shortly you can write u is cl. Now in bracket it is factored load on column divided by area of footing. Okay, factored load on column. If the working load on column is 800 kilonewton, see here 800 kilonewton, just multiply it with 1.5 into 800 is equal to 1200 kilonewton. Then this will be your factored load. Okay, area of footing, if it is a square column, if it is a rectangular column, see the step one. Okay, now next one, third, we're finding the depth of footing for shear. See, the concrete block, concrete pedestal or concrete footing will act as a member which will transmit the load over the soil. Okay, uniformly distributed the load over the soil. While distributing the load, if the top load is more than the bearing capacity of the soil, it will have settlement. Okay, and if not, it will transmit, or the upward soil pressure it will cover up, and that particular time it will create a shear force. Okay, shear force over here. Okay, or over here, one way or two way shear. Okay, now for that particular procedure we will find the depth for shear of footing. Now tau v, nominal shear stress, is less than equal to ks into tau c. Okay, tau v is nominal shear stress and tau c is equal to shear stress in concrete. Okay, up to here it is clear, but ks is equal to 0.5 plus beta c, and beta c is equal to short side of column divided by long side of column. Okay, the value of beta c is less than equal to 1. It means that if the value is 1.2, you are not going to take this value, you will go for this value. Okay, then the next one, tau c, shear strength in concrete, 0.25 root fck, characteristic strength. Okay, by this you will find out one way shear and second two way shear. Okay, one way shear is also called as when footing, for footing we will consider it as a long beam, and for two way shear it will consider as a punching shear. Okay, now first one, next page. See, for first, footing acting as a wide beam. See, I am drawing the plan. Okay, here will be our column. Okay, at d distance, see, at d distance, one way shear will act. Okay, d distance, the one way shear will act. Overall, this is b, this is L. Condition will be vary while calculating this distance, because in one condition we will judge this footing as square, and in next condition we will judge this footing as a rectangular footing. Okay, now we have to find this distance. How it is possible? See, this shaded area, it is the area where the shear force will act. Okay, shear force on shaded area equals to B into L minus capital D by 2 minus D in bracket PU calculated. Now see, this is D and this is D. Now see, while calculating the area, it is equal to length into breadth. Okay, right, same principle. Now B, this distance, and B L into B. Now the B distance, see the overall length. Okay, this distance minus this plus this. Okay, total minus into B. This or is equal to L in bracket B minus small b divided by 2 minus T. PU calculated. Now PU calculated is, just a minute, PU calculated is the upward soil pressure. Okay, upward soil pressure, and we have to choose the greater in both of these in terms of rectangular footing. Okay, while differentiating, this value is greater, then we will select this one. Okay, after that we are going to find the shear resisted by concrete. Okay, and for that VU, now the VU is equal to tau C BD. Okay, and this will consider as equation 2, equation 1. Okay, now next one, by comparing equation 1 and equation 2, we will find out the value of D, and D, find depth of footing. Okay, this was for the one-way shear, and for the two-way shear, second, the two-way shear means punching shear. For punching shear, we will again draw the plan of the footing. This is our column, this is our footing, and the punching, it will act over this distance. Okay, now this is the completely a shaded area where the shear force is actually acting over it. Okay, now this distance is B, this distance is L, this distance is small b, this distance is D, and this distance is D by 2, and this one is D by 2. Okay, now the shear force is acting from the face of the column at the D by 2 distance. Now in this, same, the shear force on shaded area. Now we know that area means length into breadth. Now see, the total area, we have to deduct this area. Okay, now means that L into B, total area, minus D less small d into B plus D. Okay, total area minus this one, this is equation third. And now it is the shear force on the shaded area. Now the shear force resisted by concrete. Okay, same tau C BD, VU equals to tau C BD, and this is the equation number 4. Again compare equation third and equation fourth and find depth of footing. Okay, up to here the one-way shear and two-way shear is complete. At least solve up to this step 4 to 5 times unless and until you get the complete idea over the starting portion, because the most complex portion is up to here only. The further process is quite simpler. Okay, in this step, now after that calculating the depth, then we are going to find the required depth by the bending moment. Okay, means whatever calculation up to here we did, whether it is right or not, for that we are going to check. Okay, by bending moment, bending moment calculation. Okay, now here we will again draw the plan. Again plan. See, here is our column, right? L distance, B distance, small b, capital D. Okay, now the shear force, the moment is acting right to the face of the column to the till the end of the footing. Okay, now see, this is one shaded area. Now here is the another one. Okay, here the bending moment is going through. Now how we are going to find the this distance? Okay, means the L minus D by 2. This is this distance. Okay, now this one means B minus small b divided by 2 is this distance. Okay, it means that overall distance minus the width of the column divided by 2 will be this distance. Now for this, L minus total L minus this distance, this minus this divided by 2 is equal to this distance. Okay, now the bending moment means MD is equal to, means that the maximum moment of the two calculations as above. Now the bending moment calculation is generally dependent upon the concrete mix and the grade of a steel. For example, this grade of steel is there, then the value of FCK and the value of Fy, means the value of mu limit varies. See, mu limit, mu limit and mu limit. There are generally 3 grades of steel, means Fe 250, Fe 415 and Fe 500. Okay, there are 3 different types of grade of steel. Now for Fe 250, the mu limit is equal to 0.149 FCK into BD square, and for Fe 415 that is 0.138 FCK BD square, and for Fe 500 that is 0.133 FCK into BD square. Okay, from this you will get the D required, then compare the value of D from one way and two way, it means that the greater one. Then after comparing, if after comparing you will get the proper assumption that the D required should be always less than the actual D you have taken. Okay, if satisfies the condition, then you can solve further, means for area of steel, or determine steel. Now the formula for steel is determine steel, means the AST. Now AST is equal to 0.5 FCK divided by Fy. Okay, in bracket 1 minus in root 1 minus 4.6 MD. Okay, divided by FCK BD square in bracket B into D. Okay, from this you will get the area of steel. After area of steel you will just take a actual diameter of what kind of diameter of bar you are going to assume. Okay, provide the steel along each side. Each side means in X direction and also in the Y direction. Okay, see, this was for the estimating the determine the AST. After that we will check for development length. Okay, now development length means LD is equal to 0.87 Fy diameter of bar divided by 4 into tau BD. Okay, here you will check the length is available from the face of column in both direction, and at last you are going to give the summary and reinforcement details. Okay, it means that you have to draw column. Okay, then how the reinforcement details are there. Okay, the thickness of footing, then the steel, how much it is provided and all that stuff. Okay, and the plan. Okay, in X direction and Y direction you have to denote. For example, we have provided 20 mm diameter bar in X direction and the same in the Y direction. Okay, you have to denote this. This is how the actual design procedure of the footing is been given. So see the process, and after 2 days I'm going to set the new video for that. Okay, thank you.